Going on to the third and final part of section 7.1, we will continue to look at simplifying rational expressions. That will involve some more challenging types of factoring. Not that the types of factoring are more difficult, but they're types of factoring that you may not have seen in a while or may not necessarily recall how to do at first. Again, these types of factoring are going to be reviewed and should be available by this upcoming weekend, hopefully by Thursday night, so that if you've forgotten these types of factoring, you will have an opportunity to revisit, relearn, and practice this online so that you can experience greater success in this class. 48. We have the problem here, 3a minus 2 divided by 4 minus 9a squared. When looking for a greatest common factor, we'll find that we do not have that in the numerator or denominator. When you look at the top, you'll further see that there's no other way to factor it. However, the bottom can be factored. So in the top we have 3a minus 2. The bottom is the difference of perfect squares. To factor it as the difference of perfect squares, I'll take the square root of the first term. The square root of 4 is equal to 2. And then the square root of 9a squared. Well, first, the square root of 9 is 3. The square root of a squared is a. And I'm going to write this as plus and minus. And now we have factored the denominator of the rational expression. Upon first observation, you may think, looking at this, that there's nothing that can be simplified. However, when looking at the top term and then this bottom term, where we have 3a minus 2 over 2 minus 3a, you'll notice that we get the form that we had in the last problem of a minus b over b minus a, where this reduces to a negative 1. So in the final form, we have an answer of negative 1 over 2 plus 3a. And we leave the answer in this form. So again, you are seeing this for the third time. There will be a brief video explaining this property in greater detail with some numerical examples, so this is a little easier to understand. This will be forthcoming. Going to question 50. We have a squared minus 16 over a squared minus 8a plus 16. In the numerator and denominator, there are no greatest common factors to factor. In the top, because we have the difference of perfect squares, we're going to factor this into two binomials. The square root of a squared is a. The square root of 16 is 4. And we write the signs in the middle as plus and minus. The process of factoring the difference of perfect squares is a very formulaic process. It's a formula. You need to be familiar with the formula, you need to be comfortable with the formula, and you need to be comfortable with how to take the square root of a variable and a number. And if you can do this, this type of factoring is not difficult. If we have a squared minus 8a plus 16, we're going to factor this trinomial into two binomials. Well, for a squared, this will be a times a. And then for positive 16, we're looking for two numbers that multiply to positive 16, but have a product of negative 8. The only two numbers that will do that are negative 4 and negative 4. Because negative 4 times negative 4 give a product of positive 16, but negative 4 plus negative 4 also give a sum of negative 8. When we look at what we have in this form with the factors in the numerator and denominator, we see that we have an a minus 4 that will reduce, leaving us with an answer in the final form of a plus 4 over a minus 4. So from this original problem, we simplified in lowest terms, or in simplest form, to a plus 4 over a minus 4. Let's take a look now at 52, and let's see what we can do to simplify that. We have 9m squared minus 4n squared over 4n squared minus 9m squared. Now, there may be some people, again, as you are looking at this, you may see that this could be factored rather handily by calculating the difference of perfect squares. However, if you should notice that, again, because this is here and this is here, this is here and this is here, and they're swapping out, you have something written in the form of A minus B over B minus A. This is simply equal, again, to -1. I know I've gone over this example quite a few times, but this is something that you need to be very comfortable with and you can expect to see on an upcoming test. So I want to make sure that this is clear for everyone to understand. We have 2 more examples for the lesson here before we're done. We're looking now at question 54. This is going to be a to the third plus 8 over a to the second minus 4. When you look at the top and bottom and you're looking for the greatest common factor, you'll notice that there's not a greatest common factor to factor out. So when we look for different types of factoring to apply, let's first consider the denominator, a squared minus 4. So this is going to be a, because that's the square root of a squared, to 2, the square root of 4, plus and minus. But when considering a to the third plus 8, this is not the difference of perfect squares, and there is nothing we can factor out to make it so. However, the type of factoring that is applied here is what is considered the sum of perfect cubes. This type of factoring requires a formula. So this is the sum of perfect cubes. Again, this is going to be another type of factoring that I will be providing examples for and giving students the opportunity to practice this. So the formula for this is for something that's of the form x to the third plus y to the third, it is factored in the form of x plus y over x squared minus xy plus y squared. So you will find here, let's identify what the pieces are. In this case, x to the third is equal to a to the third. So if we take the cube root of each, we can just say x is equal to a. If we look at the value of y to the third being equal to 8, from here, well, the cube root of y to the third is y. The cube root of 8 is 2. We get that because 2 times 2 times 2 is equal to 8. When we put all this into this formula, what we obtain is a plus 2 times a squared minus a times 2 plus 2 squared. To simplify this a little further, so this looks a little neater, we will have on the top a plus 2 times a squared. We don't usually write a times 2. We go ahead and write this as 2a. And then we don't leave this as 2 squared. We'll just make this positive 4. And again, this is going to be over a plus 2 times a minus 2. When you observe the trinomial here, when you factor the sum or the difference of perfect cubes. Well, we haven't gotten to the difference of perfect cubes yet, but the way it is factored is very similar. We typically cannot factor the resulting trinomial. Now, that's not always the case, but that's usually the case. So we won't look to factor this here at this time. However, when we can look at a plus 2 over a plus 2, we can reduce that. And we are left with the final answer of a squared minus 2a plus 4 over a minus 2. And that is the answer in simplest form for the following rational expression. The last question we are going to do will now explore the difference of perfect cubes, and it's going to be question 56. And let's move this up a little bit. That's going to be x to the third minus 27 over 5x squared plus 15x plus 45. So when doing these types of questions, there may be multiple types of factoring that will be necessary to complete the question. So we'll first look at the greatest common factor. In the numerator, there is no greatest common factor. However, the bottom trinomial does contain a greatest common factor, specifically of 5. So when we look to factor out 5, 5 times x squared will give us 5x squared. 5 times 3x will give us 15x. And then 5 times 9 will give us 45. So I'm going to write this down here. Now, when looking at this, one may be tempted to try to factor this right away, and some people who may be strong at this will notice quickly this does not factor. We cannot factor this particular trinomial into two binomials. But be patient and let's see what happens on the top. We have x to the third minus 27. Well, we have a perfect cube in x to the third. We have a perfect cube in 27, and we have their difference. And in fact, yes, there is a formula for the difference of perfect cubes. And that formula is as follows. And I'm just going to write it in this form so we don't confuse the x here with the formula. So if we have a to the third minus b to the third, this will be a minus b over a squared plus ab plus b squared. You'll notice that the formula above is pretty much identical with this, except in two places. The signs switch because we have the difference. So, moving this over slightly so that you can get a better view. For here, a to the third will be x to the third, so a is going to equal x. B to the third is going to be the value of 27. And if b to the third is equal to 27, then the value of b is equal to 3. Because 3 times 3 times 3 will give us 27. Putting it into the formula, we're going to get x minus 3 times x squared minus x times 3, or excuse me, not minus, please make that plus, and then plus 3 squared. So I've just put everything into the formula as I've specified here to the right. I'm going to simplify this again here, and let's see what we get. X minus 3 times x squared plus 3x plus 9 over 5 times x squared plus 3x plus 9. Well, if you happen to notice, you'll recognize that the trinomial in the numerator and the denominator here are identical. And yes, they may be trinomials, but if they are identical, they too can be reduced. So we may simplify this rational expression in its simplified form to x minus 3 divided by 5. And this will be the final answer in simplifying this rational expression. Please be sure to submit any questions that you have about this lesson. And if there's anything that was not clear in this lesson, please let me know what that is. Also, if you could let me know from the 3 lessons that you've had a chance to view, what types of factoring that you're comfortable with and what types of factoring perhaps you're not comfortable with. This information will help me to plan what will take place in the class and what videos I'll post online to support your learning. Thank you, and have a good night.